So this video is designed to discuss the worksheet from last week. You were assigned problems 2, 4, 8 through 20 even. Some of the problems may not have an X or a Y in it. So just keep in mind that the first step I mentioned is you replace the f of x with a y, maybe a g of x or an h of x. So the first step is replace f of x with y. Second step is to replace exchange the x and the y. And then from there, solve for y. So the first step is to multiply both sides by 5 to get rid of the division problem. So 5x is equal to negative 15 plus 3y. Next step is to add 15 to both sides to get rid of the negative 15. So you have 3y. So it would be 5x plus 15 equals 3y. And the last step is to divide both sides by 3 to undo the division problem. So the final answer would be 5x plus 15 over 3 is equal to y. I like the final answer written in inverse function notation. So the inverse of f of x is equal to 5x plus 15 over 3. One of the things I want to emphasize before moving on is you look at the original problem, you had negative 15. In the inverse, it's an addition or positive. In the original problem, the 3 was a multiplication problem, but in the inverse division. And in the original problem, the 5 was under division, and under inverse, it's multiplication. So keep in mind we are writing an inverse, which means that in the end, whatever operation we're beginning with, the inverse should be showing the inverse operations. So in problem 4, the first step is to replace f of n with a y. Exchange, in this case, n and the y. And then solve for y. So first step would be to multiply both sides by 2 to get rid of the division problem. And then the last step is to divide both sides by negative 5 to get the y by itself. So what we end up with is 10 over 5. The negative can be placed with the 5 or out in front, which is where I prefer it. So y is equal to the opposite of 2n over 5. Again, and then the final answer, please write it in inverse notation. So negative 2n over 5, or the opposite of 2n over 5. So again, it didn't change the sign, so it was negative to begin with, it's still negative. But the 5 is now is a division problem, where the original was a multiplication, and the 2, which was originally division, is now under multiplication. Problem 8. First step is to replace the f of x with a y. Second step is to replace or exchange the x and y. And then solve for y. So first step is to multiply both sides by 4 to undo the multiplication problem. So you have 4x is equal to 5y. And then the last step is to divide both sides by the y to get the, multiply by 5 to get the y by itself. So we have 4/5 x, or 4x over 5, is equal to y. In inverse notation, it would be the inverse of f of x is equal to 4x over 5. You might sometimes see it as written as 4/5 times x, 4/5 being the slope. So again, you may see it written in 2 different ways. But again, just emphasizing multiplication for the 5 originally, now it's under division. The 4 was a division problem, now it's a multiplication problem under the inverse. In problem 10, replace g of x with y, exchange the x and the y, and then start solving for y. So first step would be is to add 1 to both sides. So we have x plus 1 is equal to negative y. Because negative 1 plus 1 is 0. And then and this is a negative 1, so we're going to, we have two choices here. We can multiply both sides by negative 1, or we can divide both sides by negative 1. I'm going to choose to multiply by negative 1. I want to kind of emphasize here that by doing multiplication by negative 1, the multiplication will actually get done to both the x and the 1. So this creates a value of 1, which is what I'm always trying to do, is find the value of 1y. And then when I multiply by negative 1, the sign on the x becomes a negative 1, where it's originally a positive 1. And then the 1 itself, under addition plus 1, you multiply by negative 1, it makes it a negative 1. So the final answer is y is equal to negative x minus 1. Again, because you're multiplying the 1x by negative 1 and the positive 1 by negative 1. So the final answer, using inverse notation, would be the inverse of g of x is equal to the opposite of x minus 1. So problem 12, we replace h of x with y. We're going to exchange the x and the y. So the first step is to get rid of the 2. So we're going to do subtraction. So x minus 2 is equal to 3/5 y. And then we talked about this in a previous lesson. Anytime we have a fraction and I want to make the value become a 1y, we multiply that fraction by its reciprocal. In this case, it would be 5/3. That would create a fraction of 15 over 15 on the right side. 15 divided by 15 is 1. Like the previous problem, we've got to put the x minus 2 in parentheses because that problem actually gets done first, and then we're multiplying whatever that answer is by 5/3. Because the 5/3 and the 2 don't multiply well together, it means it's going to give me a fraction, we can leave it as simply 5/3 in parentheses x minus 2. So as an inverse, it would be the inverse of h of x is equal to 5/3 times x minus 2. If you went ahead and actually multiplied this together, you end up with 5/3 times x minus, and the 2 actually would become like 2 over 1. And so 2 over 1 times the 5/3 would be 10/3. So that would be the fraction. You decided to turn it into fractional form and get rid of the parentheses. Either answer is acceptable. The nice thing about the second answer without the parentheses is that the 5/3 tells me the slope, and the negative 10/3 tells me where the graph actually intersects the y-axis. All right, so first step is to replace g of x with a y. We're going to exchange the x and the y. This problem will look a lot like the previous problem. So the first step is we're going to get rid of the positive 2 by subtracting by 2, makes it a value of 0. So x minus 2 is equal to negative 3/2 times y. And again, we need to get a value of 1y, so that means I need to take the reciprocal of the 3/2, which makes 2/3. But because the 3/2 is negative, I need to make the 2/3 also negative to get a positive 1 answer. So we're going to multiply both sides by negative 2/3. And again, like the previous problem, the x minus 2 goes in parentheses because based on the order, the x minus 2 answer actually is done first, and then we're multiplying by the negative 2 last. So the final answer is the inverse of g of x is equal to negative 2/3 in parentheses x minus 2. If you decided to get rid of the parentheses to put it in the slope-intercept form, it would be negative 2/3 x and negative 2/3 times the negative 2 over 1, again, taking that negative 2 and turning it into a fraction, you get positive 4/3. So the slope would be negative 2/3, and the graph or the line would intersect at 4/3. In problem 16, first step again, replace f of x with y. Second step is to exchange the x and the y. And then solve for y. So first thing is we're going to do this division problem by multiplying both sides by 2. So you have 2x is equal to y plus 5. And then we're going to subtract 5 from both sides to get y by itself. So this ends up being 2x minus 5. So the inverse of f of x is 2x minus 5. So again, just trying to emphasize that idea of look at the original equation, look at the answer for the inverse. You notice that the addition problem of 5 is now subtraction of 5. The division problem of 2 is now a multiplication problem. In problem 18, this one here is the only one where the two fractions are separate. So kind of going back to what we did here, where this problem here, or the one previously, talk about separating the problems into a slope and an intercept. Well, we can actually go back the other direction. So what I would recommend in this problem is putting the two fractions and make it into one fraction. So giving them both a common denominator of 2. Then from there, replacing the g of x with y. Then exchange the x and the y. And then start solving for y. So first step again, you get that division problem, so get rid of it first. Then we get about 2x is equal to negative 3y plus 19. And then from there, we're going to subtract away 19 from both sides. Equates to 0. So 2x minus 19 equals negative 3y. And again, when we do this division problem, it's going to be divided by 3. And it is a negative 3. So the negative sign can be put with the 3. It can be put out in front. I would recommend that in the final answer, you place the negative sign out in front of the fraction. So it's the opposite of 2x minus 19 over 3. And then function notation, the opposite of g of x is equal to negative 2x minus 19 over 3. If you wanted to put the problem back into slope-intercept form, it would be negative 2x over 3. Sorry. And then because this is a negative going to both things, that would make the 19 become an addition problem. So placing that negative sign in front is actually like multiplying that fraction by negative 1. So it becomes a negative 2/3, and then the 19 becomes positive. But again, the fraction is perfectly okay. You don't have to separate it into two separate fractions. Last problem. Replace g of x with a y. Exchange the x and the y. First step is to multiply both sides by the 5 and get rid of the division problem. Subtract away the 15. So we get 5x is equal, minus 15 is equal to 2y. And then we divide both sides by the 2. So the final answer is F, or g. Inverse of g of x is equal to 5x minus 15 all over 2. If you have any questions, please let me know.